I invite you to join me on an exciting exploration, an adventure into the intriguing and mysterious universe that is the butterfly effect and chaos theory. Imagine, just for a moment, a delicate butterfly perched gracefully on a flower, hiding in a serene corner full of life in the vast countryside of Rio de Janeiro. At that precise moment, as if fate had chosen this moment for a purpose, this tiny winged creature carries an immense weight on its fragile wings, the ability to alter the course of nature. With a simple movement, a slight flapping of its wings, it has the potential to set off a series of events that, unbelievable as it may seem, has the power to divert a catastrophic storm predicted to devastate Japan within a week. But how can something so small influence something so great? Therein lies the beauty and mystery of the butterfly effect, a fascinating demonstration of how seemingly insignificant actions can have gigantic repercussions, shaping events on a global scale. This principle, which seems to be taken from the pages of a fairy tale, is actually a cornerstone of chaos theory, which teaches us about the inherent unpredictability of complex systems. Now imagine that this butterfly, in its ephemeral and delicate existence, represents each of our actions on a daily basis. Every decision we make, every step we take, can be the flapping of wings that generates waves of change through the fabric of the universe. This isn't just poetry, it's reality according to chaos theory, which shows us how the world is interconnected in ways we've barely begun to understand. So what does this mean for us in our daily lives? It means that we live in a world where order and chaos are eternally intertwined, where the unpredictable and the predictable move in tandem. It means that no matter how small or insignificant we feel, our every action has the potential to influence the world in ways we can't even begin to imagine. So, when you see a butterfly flying freely, remember the incredible power that lies in the simplest things. And by reflecting on the butterfly effect and chaos theory, perhaps we can begin to appreciate the wonderful complexity of the universe and our place in it. Sounds like something out of a movie, doesn't it? But here we come across the central idea of the butterfly effect. A simple action can have immeasurable consequences in another corner of the world. But is this really true? This notion, although poetic, has its roots in science, more specifically in chaos theory. Chaos teaches us that apparently ordered and predictable systems can exhibit unpredictable and complex behavior due to minimal variations in initial conditions. Isaac Newton, with his brilliant mind, presented us with a world governed by clear and deterministic laws, where gravity exists and apples fall from trees not by chance, but by a force that we can measure and predict. However, as the curtain of knowledge expands, driven by technological advances and insatiable human curiosity, we begin to realize that the universe is a much more complex and surprising stage than Newton could have predicted. In the microcosm, where elementary particles dance to the quantum rhythm, and in the vast universe, where galaxies dance to a stellar choreography, an unsettling truth emerges. Chaos not only exists, but plays a fundamental role in everyday reality. As we explore the vast unknown, from the strange quantum world to the distant galaxies that weave the fabric of time and space, we find more and more evidence that order and chaos are not opposites, but parts of a whole. The universe reveals itself not as a predictable machine, but as a dynamic work of art, full of emergent patterns, fascinating fractals and cycles that defy our linear understanding. A chaotic system, then, is one where small changes in initial conditions can lead to drastically different results. A classic example of this can be seen in the Earth's atmosphere, a system governed by precise physical laws, but whose behavior can become highly unpredictable. For example, in the case of weather forecasting. Imagine we're talking about how small things can lead to big changes, and let's use a very simple example to understand this. The logistic graph. This graph is a tool that scientists use to understand how certain things, such as the population of animals, can change over time. Now think of the logistic graph as a game where you can adjust the level of difficulty using a control called R. If the level of difficulty, the value of R, is low, the game is predictable and easy to understand. But if you increase this level too much, the game becomes unpredictable and chaotic, and small differences in your initial choices can lead to totally different results. To visualize this, imagine that you start the game with 3 almost identical numbers, as if you were playing with 3 balls in almost the same place. If the game isn't too difficult, i.e., if the value of R is low, these 3 balls will follow very similar paths and end up in the same place. But if we make the game very difficult, by increasing the value of R, even if the balls start in almost the same place, they will end up in completely different spots. This shows how small differences at the beginning can lead to big differences at the end, and this is what we call the butterfly effect in chaos theory. This idea applies to many things in the world, not just balls or animal populations. It could be the traffic in a big city, where a small delay in a car can cause a huge traffic jam, or even the weather, where small changes in the atmosphere can result in storms. Chaos, then, doesn't mean that everything is random and without rules. In fact, chaos comes from systems that follow very precise rules, but which are so sensitive to initial conditions that small variations can lead to very different results. And the interesting thing is that, even in the midst of chaos, we can find patterns, like islands of calm in a roof sea, showing that even in disorder there can be hidden order. Imagine you're adjusting the volume of your favorite music. Increasing the volume slightly can mean the difference between a pleasant listen and an overwhelming experience. Similarly, in the logistic graph, a small change in the initial conditions or parameters can turn a predictable population growth into a pattern of chaotic and unpredictable fluctuations. It's as if nature were showing us that beneath the surface of order, a sea of chaotic possibilities is always lurking, ready to emerge with the slightest stimulus. And herein lies the beauty of chaos theory. It reveals patterns, structures, and an underlying complexity to what might seem random. Chaos is not pure disorder. It is order of a different kind, which defies our linear perception of cause and effect. So when you see a butterfly flapping its wings, remember the incredible power that lies in the simplest actions. The world has connections beyond our imagination, where every choice, every movement, can unleash waves of transformation across the vast ocean of chaos. And in this awareness, we find not just a lesson in physics, but a profound metaphor for life. I hope this exploration of the butterfly effect and chaos theory has piqued your curiosity and inspired you to look at the world differently. Until next time, and always keep questioning, exploring, and discovering.